Hello, and welcome to a little video with the second part of the review for Chapter 10. And this video is just only going over problems 5 and 6, which are hypothesis tests. So problem 5 here says, the National Health Statistics Reports published in 2008 reported that a sample of 360 one-year-old boys had a mean weight of 25.5 pounds, standard deviation of 5.3. In addition, a sample of 328 one-year-old girls, typo, had a mean weight of 24.1 pounds with a standard deviation of 4.3. Can you conclude that the mean weight of boys and girls differ? That's important. Here's our level of significance. Some of our conditions have been met. Okay. So I'm going to do mean boys with the B is equal to mean of girls. And when they said differ, then we are going to plan that it's a two-tailed test. My alpha is 0.05, they said. And so I'm going to go to my notes packet here. And this is, they're independent samples because that means that the girls and the boys are not a paired data set. And so this would be considered 10.1, which is page 306 in your formula packet. And so we're doing the two-tailed test. And we're going to have a T0 for our test statistic, which is going to come out of the little program in Desmos. You will not be calculating this by hand, so you need to know how to use the Desmos little program. I'm going to show you today. You could do this either the classical approach or the p-value. However, we're going to use the p-value because we're not calculating the T0 ourselves, and our degrees of freedom are going to be a little off. So we're going to use the p-value approach. So I'm going to set myself up. Remember that you should be clearly identifying all 6 steps. Some of you in your homework, it's very hard for me to read your homework because you're not labeling your steps and it's kind of all just one big clumped answer. So it's a two-tailed, so it's going to look something like this. And then we're going to be comparing our p-value to our alpha, which is 0.05. And then, of course, we're going to have our conclusion at the end. So let's go ahead and go to Desmos and put this into our 2 independent means. So we are going to go up here, and our sample size for the boys was 360. The mean was 25.5 with a standard deviation of 5.3. And the sample size for the girls was 328 with a mean of 24.1 pounds. Standard deviation of 4.3 pounds. And we're testing that there's no difference. So we're going to have the 0. And we're testing at 0.05. And we're going to go all the way down to the one that says equal to, that we're testing and not equal to. There is our test statistic at 3.81. And our p-value is 0.00016. So it's very small. This is not very likely to happen. So going back to our paper, we can then say that our p-value is less than alpha. And that's how we know that we're going to reject H0. So we do reject H0. And in number 6, we say there is sufficient evidence. To support the claim. that the 1-year-old weights differ. I'll just scratch that out. So you need to know for chapter 10, you definitely need to know how to use the little programs. I made a module in Canvas that is just all of the little Desmos links that I think should support you for the different programs to use. So that's number 5 on the chapter 10 review. Let's look at number 6. Number 6 says, a company studied 2 programs for compensating its sales staff. 9 random salespeople participated in the study. In program A, the salespeople were paid a higher salary plus a small commission for each item they sold for 6 months. In program B, the same salespeople, so the same salespeople, that tells you that it's paired because it's salesperson number 1 using pay program A versus pay program B. So the salaries are in thousands of dollars, which isn't really a necessity to look at because the comparisons are equal. So because it's the same salesperson on each 9 salespeople, we're going to get a difference. And because it's a single difference, we're just using a single mean. And so this is the Desmos 10.4 because it's matched pairs data. This is page 305 in your formula sheet. And we want to know, it says find the differences. And we did here, I'm going to show you how I did them in Desmos as well. Can you conclude that the mean sales differ between the 2 programs? So it looks like another not equal to. Use the p-value method at 0.01. So we're going to follow this not equal to. Notice when it's matched pairs, we don't do mean of A equal to mean of B. We do just testing the mean difference is not equal to 0. And our alpha is 0.01. And again, we're going to have a T0, and we'll get that from our Desmos link. And then we are going to have a step 4, which is our picture. And since it's 2-tailed, we'll have a little bit of a tail on both sides here. And we're going to, again, do the p-value versus the alpha of 0.01 this time. And because it's a single data set of differences, we're going to have to get the mean of the differences and the standard deviation of the differences for Desmos. So let's go ahead and go to the Desmos link that I created. And you'll see in the link that, yes, there's folders for the data sets from problems 1 through 4, but we're not working on those in this particular video. Okay, so we're looking at problem number 6. I'll open that up here. And there are, there's my data set A for program A, and then salary for program B. And then I calculated the differences. And then we're going to need to get the mean of the differences. So my data is an X3 minus Y3. I want the mean of the differences. And then I would like the standard deviation of the differences as well. And we're going to need to jot those down because we'll need them in the little program. So the mean of the differences is a negative 2.56, and the standard deviation is 2.603. Now, because this is a single data set, we could use the classical approach. It's not too hard to calculate. So I could calculate our test statistic here by taking the sample mean of a negative 2.56 and subtracting what we think it should be, which is 0, and then dividing by the standard deviation divided by the square root of n. No. Which is 9. There were 9 salespeople. So that's our test statistic, and we'll be able to validate that in the little program. So our test statistic should be 2.9, a negative 2.95. So I'm going to my means for one sample, and we had 9 as our sample size. Our mean differences was a negative 2.56. Our standard deviation of the differences was 2.603. And we think our differences should be 0. So don't forget your H0. And our alpha is 0.01. And we're doing a not equal to, so I can close the confidence interval. I'm going to close all of them except for I'm going down to the one that is the equal to test my two-tailed. And that validated my test statistic. And it's okay that it came out positive because they're symmetric. We're just doing a two-tailed not equal to. So my p-value is 0.018. Make sure you enter everything correctly up here. And let's go back to our paper here and see that we'll compare to alpha. And my p-value is slightly bigger than alpha. So we do not reject H0. Now, because I had 9 in my sample size, I could use a comparison of T with the degrees of freedom of 8 and 0.01. So let's look that up in our table. So T of 8 and alpha 0.01. So 0.01 right here and 8 would be 2.896, it looks like. And for me, it would be a negative 2.896. Now, remember, some of you also, when you're doing these critical values, remember that they're symmetric. So if you have a greater than as your HA, then you have to use the positive of your T critical value. If you have a less than left-tailed test, you have to use the negative critical value. So make sure you're thinking about that. This is a two-tailed, so because my critical value or my test statistic is a negative 2.95, which is just outside um 2.896. So it's just outside. So I think this is a weird one where this came out to be just in the danger zone barely. So the test statistic does kind of show that it is in a danger zone. Interesting. For our differences. So using the classical method, it looks like it would reject because my T0 is less than my T of degrees of freedom of 8 and 0.01. So it's barely, barely. It's at negative 2.95, and the critical value is a negative 2.896. So we do reject. And I think it's just that calculation is just borderline, probably on the rounding here. So depending on which one you use, we have not ran into that situation before, but let's just go back and check out the data and make sure our data is typed in correctly. So there is our sample size is 9 and 2.603. And there is our test statistic, and there's our test statistic. And then there's our p-value on the not equal to 0.018. So yep, it's just, whoops. Let me get out of there because I accidentally bumped that. So, so yes, it is confirmed that just due to rounding, it did produce a different because our typical T at 0.01 and 8 with the degrees of freedom is 2.896. And so it's just right there borderline with this negative 2.95. So very interesting. Oh, no, we had to divide by 2. I forgot. That's where it was. Our alpha for the critical value has to be 0.005 because we have to divide our alpha by 2 on the critical value. So I should be looking at 0.005. I did mix up. So it does bring it up to 3.355, a negative 3.355, and it's not less than, it's greater than. So we do not reject. Okay, I thought they could match, and I was thinking that maybe it was just some kind of a rounding that caused that issue. But I just remembered that we had to do alpha divided by 2. So that would give us a critical value of a negative 3.355. And so we are not in the danger zone. So this is a negative 0.35, and our our T0 is not in the danger zone. So there is not sufficient evidence. Also, when you're writing out your step 6, we don't write there is insufficient evidence. It is there is not sufficient evidence to support the claim that there is any difference in the compensation plans. Salary compensation. There is not sufficient evidence to support the claim that there's any difference in the salary compensation difference. So I'm glad I caught that. In the p-value method, you always just use alpha, okay? And that is so. In the classical method, if it's a two-tailed, you have to do alpha divided by 2, and that's where I mixed up. So it should have been a critical value of a negative 3.355, and compared to our test statistic of a negative 2.95, which is actually greater than. So we do not reject using either method. And catch me back for other reviews.